In this video, we will be learning how to conceptualize z-scores. The question asks, or tells, Judy, who is 25 years old, has her bone density measured using DEXA. Her results indicate a bone density in the hip of 948 grams per centimeter cubed, and a standardized score of z equals negative 1.45. In the reference population of 25-year-old women like Judy, the mean bone density in the hip is 956 grams per centimeters cubed. So now, let's look at question A. Judy has not taken a statistics class in a few years. Explain to her in simple language what the standardized score tells her about her bone density. So, her standardized score tells her her bone density is 1.45 standard deviations below that of the mean bone density for the survey, for the population. She knows it is below the mean because it is negative. It's a negative 1.5. Now, in this case, the standard deviation is 5.517 grams per centimeter cubed for this set of data. Now, this means, and a side note, a standard deviation is a measure of how much a group of data varies. Now, this means that her bone density is 8 grams per centimeter cubed below the mean bone density of her age, and we got this 8 by multiplying this 5.517 by the 1.45. Now, she also knows that her bone density is below normal in average people because her standardized score is over 1. Or in this case, negative 1, because it's a negative 1.45. So, she's well out of the negative 1 to 1 range where people's bone densities are considered normal, which is the standard deviation range, or the standard range where the average 25-year-old can vary. This negative 1 to 1 range is where people's bone densities that are regular can vary, but hers, since it's negative 1.45, is out of this range. So her bone density is irregular and irregularly less since it is a negative 1.45. Now, moving on to part B. Use the information provided to calculate the standard deviation of bone density in the reference population. So, the question is asking for the standard deviation of the bone density. And now, in the original problem, let's go back to the original, and let's see what we are given. So in the question, the important pieces of data we are given are the z-score, which is the negative 1.45. We are given the mean bone density, which is the 956 grams per centimeter cubed, and we're given her x value, which is hers, which is the 948 grams per centimeter cubed. And obviously, since now we have the variables, these variables are used for calculating z-scores, so we will write our formula out, which is this. And these are our three pieces of data, our z, our u, and our x that we were given. So now let's go back. So now we are looking for our standard deviation, and since we were giving three pieces of data, these three pieces of data, from the beginning we have 3 out of our 4 pieces of data that we need for our z-score formula. So we have our z, our x, and our u, and we need our o, which is our standard deviation. So we can plug these 3 pieces of data that we were given into this formula, do some algebra, and that will give us our answer. So let's do that. We have our formula here. We plug in our x, we plug in our u, and we plug in our z, and then we try to find our o. Let's take this chunk, move down here, and do the algebra. So now, to get this o out of the denominator, we times it on both sides, and this will cancel it out to get it out of the denominator on this side, and move it over to this side. So now, we carry our 948 minus 956 down, and do this calculation, which turns out to be negative 8. And we also carry our negative 1.45 times our o down as well. So now we carry this down even more, and we have our negative 8 equals our negative 1.45 times our O. So now to get this O isolated, we can divide by our negative 1.45 on both sides. This will cancel out to get our O isolated. And this negative 8 divided by this negative 1.45 will give us our 5.5172, which is our O value, which we were looking for, which is our standard deviation. And now, since we have solved both, we will now learn or know how to conceptualize Z-scores.